Hello everyone. Today we will be discussing the standard forms for the simplification of a logical function. Any logical function can be simplified by expressing it in two standard forms. These are the standard sum of products form and the standard product of sums form. So these are the two standard forms in which we can express any logical function. We will discuss the first of these forms, that is the standard sum of products form, in detail. Let us consider the following logical expression: f a b c d is equal to a bar b plus bc plus a bar cd plus bcd, which we have already discussed in the previous lecture on the sum of products. From this expression of equation 1, we notice that the individual terms do not involve all the four variables a, b, c, d. The first term does not involve the variables c and d. The second term does not involve the variable a and d. The third term does not contain the variable b, and the fourth term does not contain the variable a. So this form is simply called the sum of products form. We do not call it the standard sum of products. So we will now derive a standard form leading to an expression in which all the terms will involve all the variables, either complemented or uncomplemented, as shown in the example below. And that form will be known as the standard sum of products form. So let us understand the standard sum of products form with the help of the example. We are given an example in which there is a logical function of three variables f a b c is equal to a plus b bar c. Here we find that the individual terms do not involve all the three variables, so we have to write this expression of equation 2 in such a way that all the three variables do appear in each term. So let us see how we can write this logical expression in such a way that all the individual terms involve all the three variables. From this equation 2, we find that the first term does not contain the variable b, neither c. So we will multiply the first term by b plus b complement into c plus c complement. This will not affect the operation because we know from Boolean algebra that b plus b complement is 1, c plus c complement is 1. So simply we are multiplying the first term a by 1. So we have multiplied the first term by b plus b complement into c plus c complement. Similarly, we find that the second term does not contain the variable a. So we will multiply this term with a plus a complement. So we will multiply the second term by a plus a complement. After multiplying the first term by b plus b complement into c plus c complement and the second term by a plus a complement, the equation 2 will come out to be f a b c is equal to a multiplied by b plus b complement into c plus c complement plus a plus a complement into b complement c. Now using the distributive law, we can write this as, that is, we have applied distributive law to this expression. So after applying distributive law, This can be written as FABC is equal to ABC plus ABC complement plus AB complement C plus AB complement C complement plus AB complement C plus A complement B complement C, which we have written here. Now from this expression we find that these two terms are duplicate terms, that is, they have been repeated twice in this expression. So we will eliminate one of these terms, and so the expression comes out to be FABC is equal to ABC plus ABC bar plus AB bar C plus AB bar C bar plus A bar B bar C. Let this be equation 3. Now from this equation 3 we find that this is the sum of products. The individual terms are the products of the variables, and we have taken the sum of all these products. So this is a sum of product form. But in this case we find that each individual term involves all the three variables, either complemented or uncomplemented. So we find that all these terms contain all the variables. So this form of the sum of products, where all the individual terms involves all the variables, is known as the standard sum of products form. And when we have expressed any logical function in the standard sum of products form, then each individual term is referred to as a Minterm. That is, when we express any logical function in the standard sum of products form, then each of the individual terms is called a Minterm. So from this expression we find that this function ABC has 1, 2, 3, 4, 5 Minterms. These are called the Minterms. This is one Minterm, this is the second Minterm, this is the third Minterm, this is the fourth Minterm, this is the fifth Minterm. Now what is the advantage of the standard sum of products form? That is, why do we express any logical function in the standard sum of products form? The advantage of the standard sum of products form, as we have obtained in the equation 3, is that certain information about the logical function becomes immediately available upon inspection. That is, just by inspection we can get several information about the logical function. So this is the advantage of the standard sum of products form. In the next lecture we will be discussing the second standard form, that is the standard product of sums form.